Alright, this is a pretty fun problem here actually, because we're combining what we know about strings and how they vibrate and resonate with those of tubes, in this case a closed-ended tube, a tube closed on one end. So if you did not watch the video earlier, you'll want to watch the video I posted about closed-ended tubes. Okay, so as far as strings are concerned, we know the velocity of a wave on a string is expressed by this equation, and the velocity of any wave is lambda f. Okay, so they give us mass and length, so we'll have to convert that to meters, put that in for length, convert this to kilograms, put that in for mass. Okay, this point we don't know the velocity, but we know that the velocity equals lambda f. Okay, and we know that for a string that is attached at both ends, that this expression lambda n equals 2L over n is true, and since it's the fundamental that pretty much vibrates when you pluck a string, we would use n equals 1, right? So again, using this, convert to meters, plug that in for L, that gives you lambda. That gives you the fundamental wavelength that you're going to be able to plug into there, all right? And then that's as much as we can do with the string because they didn't tell us the tension, okay? Now let's look at what we know about the tube. From the video earlier, I explained why for tubes closed on one end, a closed-ended tube, lambda n equals 4L over n, different pattern. Again, this is the fundamental frequency, so n equals 1, so the wavelength of the first resonant frequency will equal 4L over 1 since n equals 1. And since the tube is this long, 4 times 2.15 equals 8.6 meters. So that's the wavelength of the resonant wave that's resonating inside that tube. So that equals that number right there. Now the thing with sound is we just can assume the speed of sound is 343 meters per second. That allows us to find the frequency of the sound wave. Now, since we know that what happens in this case is that the string is plucked and causes the tube to resonate, these must be the same because that's what resonance is, an external force. In this case, the string vibrating is creating this external vibration that resonates with the tube. So they must have the same frequency since they're resonating. Now that we know frequency and wavelength, we can find V for the string, which is not 343 meters per second. It's much faster probably. But we know, so now that we know V, then we can solve for the tension in the string.